In this video, we're going to talk about rules for differentiation. So basically, we're going to talk about shortcut. Rule number one is derivative of a constant function. If f is a function with a constant value c, so for example, if f of x equals c, in other words, f of x could be equal to 5, f of x could be equal to -2, any real number, c. Then derivative of f respect to x, that's what df over dx means, is d over dx, which means the derivative or the slope of c, which is always going to be 0. So take a look at f of x equals 5. If you graph this, you get some kind of a horizontal line, right? Now, what is the slope of that line? It's 0. So f prime of x is 0. What about f of x equals -2? Same thing, it's a horizontal line going through y value of -2. So f prime of x is 0. So they're saying that derivative of any constant or any real number will always be 0. Rule number two, power rule for positive integer powers of x. If n is a positive integer, which is exponent of x, then derivative of x to the n equals n times x to the n minus 1. So for example, let's say you have f of x equals x to the third. So what will be the derivative? Well, here our n equals 3. So it will be the derivative of x to the third power is 3x, and what's n minus 1? That's 2. So it's 3x squared. That will be the derivative of x cubed. What if you have f of x equals, let's say, x to the 100? What will be the derivative? Well, now here the n is 100, so it's going to be n, which is 100, times x to the n minus 1, which is 99. So as you can see, if you were to do this by definition of derivative, it would take a long time. And now we have a shortcut. Rule number three, the constant multiple rule. So if u is a differentiable function of x and c is a constant, then derivative of cu is c times the derivative of u respect to x. So basically, if you have, let's say, f of x equals 4x cubed. Here the constant will be 4, right? And remember, we just took the derivative of x cubed. What is the derivative of x cubed? Well, that was 3x squared using the power rule. So the derivative of 4x cubed is 4 is a constant, so we leave it alone. And what is the derivative of x cubed? It's 3x squared. So you end up getting 12x squared. So another way of looking at it is this. If you have f of x equals 4x cubed, what you could do is, when you take the derivative, if this is a constant, just multiply them. 3 times 4 will be 12. And you get x, 3 minus 1 is 2, so you get 12x squared, which is the same thing as the answer we got over here. Next, we got the sum and difference rule. If u and v are differentiable functions of x, then their sum and difference are differentiable at every point where u and v are differentiable. So if taking the derivative of u plus or minus v, then this will be equal to derivative of u respect to x plus or minus derivative of v respect to x. So let's say you have f of x equals x to the third plus x to the 100. So what will be the derivative of this function? Sum of these functions. So you get, what's the derivative of x cubed is 3x squared. Plus, what's the derivative of x to 100? It's 100 x to the 99. So you're just doing it, taking the derivative separately. So let's say you have now h of x. Let's say h of x equals 2x squared minus 5x to the fourth. Now we have a difference of functions. So what is the h prime of x? It's going to be the derivative of 2x squared, which is the same thing as 2 times 2x minus 5 times 4x to the third. So you clean it up, you're going to get 4x minus 20x to the third. So using our rules, let's try to find dp over dt. So what does that mean? It means taking the derivative of p respect to the variable t. So we got p equals this function in terms of t. So how do you find dp over dt? Again, this is taking the derivative of p with respect to the variable t. So you get derivative of t to the fourth is 4t to the third. And what will be the derivative of this? That's going to be positive 5 times 2t. And what will be the derivative of that? That's going to be just negative 2 over 3. Because think about it, the n is 1. N is 1 here. So negative 2/3 times, what's the derivative of t? Since n is 1, you're going to get 1 times t to the 0, and t to the 0 is 1. And what's the derivative of a constant? Is 0. So you end up getting 4t to the third plus 10t minus 2/3. Now let's take a look at this example, finding horizontal tangents. Does the curve y equals x to the fourth minus 2x squared plus 2 have any horizontal tangents? If so, where? Well, what do they mean by horizontal tangents? Let's say you have a function. You will have a horizontal tangent when the tangent line at a certain point has a slope of 0. So in this case, let's say this was a function. This is not the graph of this function right here, so be careful. I'm just giving you a random example. So you would have a horizontal tangent at that point, and this point, where the slope of a tangent line is 0. So in order to find the horizontal tangent of this function, or this curve, we need to find when the derivative, which is the slope of this function, is 0. So first, let's find the derivative. It's 4x cubed minus 4x, and then derivative of positive 2 is 0. So we don't have to put anything there. So now set the derivative equal to 0, and we have to solve for x, because that's where the horizontal tangent will occur at. So take out the common factor, which is 4x. And you could factor out the x squared minus 1. So it looks like x will be 0 at when x equals 0, when x equals 1, and when x equals negative 1. So we do have horizontal tangents when x equals 0, when x equals 1, when x equals negative 1. And let's graph this and see if it makes sense. So we're going to graph this curve. Okay, depending on your window, your graph might look a little different. I did zoom standard, and I did zoom in. So as you can see, you have a horizontal tangent when x equals -1, when x equals 0, and when x equals 1. So our graph supports our answers. Also notice that our horizontal tangents occur at a minimum and maximum. So if you were to use your calculator to find the horizontal tangents for polynomials, what you do is you find the minimum and maximum near that region, around that area.